Welcome back. Hope you hung in there, right? Hope you hung in there. So welcome back to this session. We shall continue our discussion on finding the inverse of a 3x3 matrix, and this is part 2. Please, before you move on with this video, it is highly recommended that you have viewed inverse of a 2x2 matrix part 1 and part 2, then inverse of the 3x3 matrix part 1. In fact, I highly recommend that you view the videos in the playlist on matrices and determinants, because that is where we are following the videos there. These matrices here was got from the video on determinants part 2. So in this video we shall find the inverse of a 3x3 matrix using the row reduction method. That was the second method we talked about earlier on in previous videos. So in this video we shall use the row reduction method, and we shall find the inverse of matrix A, and also we will check it. We will check our work because we have not done that with the row reduction method. So we shall use the row reduction method, find A, and check our work. But for B, we will not need to check because we checked it in the video on part 1. We got the inverse of this matrix and we checked it. So if we use the row reduction method and get this right away, then we will not need to check. For question 3, we will still use the row reduction method to show that there is no inverse, that matrix E does not have an inverse. And then for number 4 matrix, the number 4 in that video is a 4x4 matrix. So we are dealing with 3x3 matrix. So it's a 4x4 matrix. Alright, so let's go ahead. Row reduction method. In using to find this matrix. We talked about this extensively in inverse of a 2x2 matrix, part 2. So please, we have discussed this extensively. We shall now apply it right away to find that of the 3x3 matrix. So we have this is number 1. A is 2, 0, 1 by column. -3, 0, -2, -4, -1, 1. From what we discussed earlier in the previous video with the row reduction method, we see that A and I will be A inverse. Augmented matrix of matrix A and then the identity matrix. We transform it to identity matrix, and then what is remaining here will be the inverse of matrix A. Right? So that was what we talked about in the previous video. So we have this, we write this in augmented form: 2, 0, 1, -3, 0, -2, -4, -1, 1. 1, 0, 0, 0, 1, 0, 0, 0, 1. The identity matrix. Okay, now we apply the row operations. This is already 0, so we make this to be 0, right? So this will be what? R1, negative R1 plus 2 R3. From what we discussed earlier about writing the row operations. So this will now be what? R1 and R2 does not change. So we have 2, -3, -4, 1, 0, 0. R2 does not change also. So we have 0, 0, -1, 0, 1, 0. Then -2 plus 2 is 0. -3. Negative 3 is 3. 3 plus 2 times negative 2 is negative 4. So 3 minus 4. 3 minus 4 is what? Minus 1. Then negative 4 is 4. 4 plus 2. 4 plus 2 times 1 is 2. 4 plus 2 is 6. Right? And we shall still check this. We shall still check it to see whether we are right. And here, negative 1 plus 0 is negative 1. 0, 0 is 0. 0 plus 2 times 1 is 2. So we got this. And now we are supposed to make this to be, this is supposed to be 1. This is supposed to be 1, but it's not 1. So what do we do now? Can we interchange? If you look at this now, if you look at this for a minute, you see that this is supposed to be 1, but it is not 1. It is 0. So you can interchange. You can interchange 2 rows, and it will still be the same. I mean, you will still have the same result. You can interchange. So because we want this to be 1. Remember, at the identity matrix we want should be 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the identity matrix we want. And we have made this 0, 0, which is fine. We are interested in the zeros first. We are not interested in making this to be 1 right now, no. Let's get out the zeros first. We have talked about it before. Then this is supposed to be 1, but this is 0. So why don't we interchange these 2 rows? And this is the way we write it. We write it like this. R2 interchange to R3. It is a double-sided arrow. Double-sided arrow. And when we do that, what do we have? We have 2, negative 3, negative 4, 1, 0, 0. Then R2 becomes R3, R3 becomes R2. So this is 0, negative 1, 6, negative 1, 0, 2. If you're interchanging, you interchange everything. Then this is 0, 0, negative 1, and this is 0, 1, 0. See that? So now the next thing is to do what? Make this guy to be what? 0. Make this guy to be 0. And what's the operation we use here? The operation we use, we won't bother arrow 3. We need to work on an arrow 1. And this will be what? 3 arrow 2, 3 arrow 2, negative 3 arrow 2 plus arrow 1. Right? Negative 3, 3 plus 3, 0. So negative 3 arrow 2 plus arrow 1. So who does not change? Which rows do not change? Row 2 and row 3. So we write it first. 0, negative 1, 6. Negative 1, 0, 2. Then 0, 0, negative 1, 0, 1, 0. Alright, so these guys change. Row 1 changes. Negative 3 times 0, 0 plus 2 is 2. Negative 3 times negative 1 is 3. Minus 3 is 0. Negative 3 times 6 is negative 18. Negative 18 minus 4 is negative 22. Negative 3 times negative 1 is 3. 3 plus 1 is 4. 0, 0 is 0. And then negative 3 times 2 is negative 6 plus 0, negative 6. Okay, so we've made this guy 0, 0. That's fine. So the next guy is to make these 2 guys 0, 0. Zeros, these 2 guys. So what is the operation we use? The operation we use is we want to use this guy to operate on these two. So this will be 6R3 plus R2 and negative 22R3 plus R1. Right? 6R3 negative 6 plus 6, and then negative 22R3, 22 minus 22, that's 0. Right? Now what do we have here? Let's now see what we got. So this will be from here, I'm working from here. This will be R3 did not change, so let's write it 0, 0, negative 1, 0, 1, 0. Then R2, 0, 0 is going to be 0. 6 times 0 is 0, plus, minus 1 is minus 1. 6 times minus 1, minus 6, plus 6, 0. 6 times 0, 0, minus 1 is minus 1. 6 times 1, 6, plus 0 is 6. Then 6 times 0, 0 plus 2 is 2. Then for R1, negative 2, R1, negative 22 times 0 is 0, plus 2 is 2. Negative 22 times 0 plus 0 is 0. Negative 22 times negative 1, 22, minus 22 is 0. Negative 22 times 0 is 0, plus 4 is 4. Negative 22 times 1 is negative 22, plus negative 22 plus 0 is negative 22. Then negative 22 times 0 is 0. 0 minus 6 is minus 6. Let's check it again. Negative 22 times 1, negative 22. Then times 0 is 0, minus 6, minus 6. Alright, so we have established what we want. We now make it to look like an identity matrix. So what operations do we have, folks? What operations do we have now from here? We have a R1 divided by 2. Then we have a negative R2. And we also have negative R3. Negative 1 times R2 and negative 1 times R3. So what do we have here? We now have 1, 0, 0. 4 divided by 2 is 2. Negative 22 divided by 2 is negative 11. Negative 6 divided by 2 is negative 3. Then this will be 0. Negative negative 1 is 1. 0. Negative negative 1 is 1. Negative 6. Negative 2. Then this is 0, 0. Negative negative 1 is 1. Then this is 0. This is negative 1. And this is 0. So this becomes I. This is your I. And this is your A inverse. So what is your A inverse? A inverse is what now? What is it? This is now 2, 1, 0, negative 11, negative 6, negative 1, negative 3, negative 2, 0. Do we stop here? No. We have to do what? Check. And the check is from this. You remember the check. The check is from what now? What? From what? What principle is the check? That A times A inverse is the same thing as A inverse times A, and it's equal to I, an identity matrix. This is what we are using to check. So if you want to know whether we are right, we've got to multiply A times A inverse. And that is A inverse. If you also want to do A inverse times A, that's fine. So you see that this is a 2 by 2 matrix, and this is a 3 by 3 matrix, right? Let's kind of write it here so you kind of see. This is A times A inverse, and we will have A inverse. Now let us check the conformability for multiplication. This is a 3 by 3 matrix. This is a 3 by 3 matrix. Because the number of columns of matrix A is equal to the number of rows of the inverse of matrix A. The number of columns of matrix A is equal to the number of rows of matrix A inverse. Therefore, it is conformable for multiplication. And then what will be the order of this? This will also be a 3 by 3 matrix. Alright folks, let's now multiply them. This will be row by column 2 times 2 plus negative 3 times 1 plus negative 4 times 0. 0 times 2 plus 0 times 1 plus negative 1 times 0. 1 times 2 plus negative 2 times 1, 2, 1, 0, plus 1 times 0. Then the second column, 2 times negative 11 plus negative 3 times negative 6 plus negative 4 times 1 times negative 1, right? 2 times negative 11 plus negative 3 times negative 6 plus negative 4 times negative 1, 0 times negative 11 plus 0 times negative 6 plus negative 1 times negative 1, 1 times negative 11 plus negative 2 times negative 6 plus 1 times negative 1. This is the second column. The third column, 2 times negative 3 plus negative 3 times negative 2 plus negative 4 times 0, 0 times negative 3 plus 0 times negative 2 plus negative 1 times 0, then 1 times negative 3 plus negative 2 times negative 2 plus 1 times 0. Alright folks, what do we, let's find out what we have. What do we have now? 2 times 2 is what? 4, minus 3 plus 0. This is a 0 plus 0 plus 0. This is a 2 minus 2 plus 0. 2 minus 2 plus 0. Then this is a negative 22 plus 18 plus 4. This is 0 plus 0 plus 1. Because negative 1 times negative 1 is 1. Then this is negative 11 plus 12 minus 1. Negative 11 plus 12 minus 1. Then this is a negative 6 plus 6 plus 0. This is a 0 plus 0 plus 0. And this is negative 3 plus 4 plus 0. So what do we have? We now have what? 4 minus 3 plus 1 plus 0 is 1. 0, 0, 0, 0. 2 minus 2, 0 plus 0 is 0. Negative 22 plus 18 is negative 4. Negative 4 plus 4 is 0. 0 plus 0, 0 plus 1, 1. Negative 11 plus 12 is 1. 1 minus 1 is 0. Negative 6 plus 6, 0 plus 0, 0. 0, 0, 0, 0. Negative 3 plus 1 plus 4 is 1. 1 plus 0, 1. So you see, it is a 3 by 3. It's a 3 by 3 identity matrix. So that means we're correct. That means we're correct. And if you want to do A inverse times A, it's still the same thing. Then I give you an identity matrix. That shows we're right. Alright, for question 2, B inverse. B, we found B inverse using the formula method, part 1. And we checked it in that part 1. We checked it, we multiplied it. So to save time in this video, we will just find the inverse using the row reduction and see whether we will get this. If we get this, yeah, good. If we don't get this, we're in trouble. Right? So let's go ahead and find B inverse. B inverse. Question 2. B is 1, 2, negative 1, 4, 3, 2, negative 1, negative 2, 3. So, to find our B inverse, we have to write this as augmented matrix. 1, 2, negative 1, 4, 3, 2, negative 1, negative 2, 3. And an identity matrix here, 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's do the row operations. What we got here? We want to make this 0, 0, right? So this will be what we want to use row 1 to operate. So this is negative 2 R1 plus R2, and this is a R1 plus R3. R1 plus R3. So what do we have? R1 is unchanged. We leave it. 1, 4, negative 1. 1, 0, 0. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 4, negative 8 plus 3 is negative 5. Negative 2 times negative 1 is 2. 2 plus minus 2 is 0. Then negative 2 times 1 is negative 2. Plus 0 is negative 2. Negative 2 times 0 is 0. Plus 1 is 1. 0, 0, 1. 0, 0, 0. Arrow 3. 1 plus minus 1. 1 minus 1 is 0. 4 plus 2 is 6. Negative 1 plus 3 is 2. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Right? We've got this. Remember, we want to put it as identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. By row. So the next one, we got your next operation. We gotta make this 0 and 0. So we have 4R2 plus 5R1, because this is positive negative. 4R2 plus 5R1, negative 20 plus 20. Then this will be 6R2 plus 5R3. 6R2 plus 5R3. So R2 is unchanged. Let's write it first. 0, negative 5, 0. And negative 2, 1, 0. We write it first. Then 4 times 0, 0. Plus 5 times 1, 5. 4 times negative 5, negative 20. Plus 5 times 4, 20. Negative 20 plus 20 is 0. 4 times 0, 0. 5 times negative 1, negative 5. 4 times negative 2 is negative 8. Negative 8 plus 5 times 1, 5. Negative 8 plus 5 is negative 3. 4 times 1, 4. Plus 5 times 0, 0. 4 times 1 is 4. 0, 0 is 0. 6 times 0, 0, 0 is 0. 6 times negative 5, negative 30 plus 30 is 0. 6 times 0, 0 plus 5 times 2, 10. 6 times negative 2, negative 12. Negative 12 plus 5 is negative 7. 6 times 1, 6 plus 0 times 5, 0. 6 times 1 is 6. And then 6 times 0, 0. 5 times 1 is 5. We've made it 0, 0. See that? The next thing is to make this guy. Actually, this is now 0. That's fine. So we now make this guy 0. We just make this guy 0. So what operation do we use? What row operation do we use? We just use arrow 3 to operate on arrow 1. And this will be arrow 3 plus 2 arrow 1. Arrow 2 and arrow 3 do not change. We leave it like that. 0, negative 5, 0. Negative 2, 1, 0. Then 0, 0, 10. Negative 7, 6, 5. 0 plus 2 times 5 is 10. 10 is here. 0, 0 is 0. Uh, 10 plus 2 times negative 5. Negative 10. 10 minus 10 is 0. Negative 7 plus 2 times negative 3. Negative 7 plus 2 times negative 3 is negative 6. Negative 7, negative 6 is negative 13. 6 plus 2 times 4. 6 plus 2 times 4. 2 times 4 is what? 8. 6 plus 8 is what? 14. 5 plus 2 times 0, 0. So this is 5, just 5. 5 plus 5 plus 2 times 0. Alright folks, let's now put this 1, 1, 1. So what's the operation here? This is R1 over 10. Then this will be negative R2 over 5. Negative R2 over 5. Then R3 over 10. R3 over 10. You see that? So what we got, folks, what we got here, we now have 10 divided by 10 is 1, 0, 0. Negative 13 over 10, 14 over 10, 5 over 10. Then we have 0, 1, 0. Negative negative 2 is 2. 2 over 5. Then negative 1 over 5. And 0 over 5 is 0. 0 over 5 is 0. Then 0, 0, 1. Then we have a negative 7 over 10. We have a 6 over 10. And we have 5 over 10. So this is our B inverse. This is our I, and this is our B inverse. So let's kind of simplify it now. What will our B inverse be? Negative 13 over 10. 7 over 5, 1 over 2, 2 over 5, negative 1 over 5, 0, negative 7 over 10, 3 over 5, 1 over 2. Is it the same thing? Negative 13 over 10, 7 over 5 over 2, 2 over 5, 3 over 5. Yo! It's the same thing, you see? And we have checked this in the part 1, so we won't come and start multiplying again. Let's keep this video sharp. Okay, sharp. Let's keep it sharp. So, but it's the same thing. Yay! Alright, the last but not the least, E. When we did E with the part 1, we found that it had no inverse because the determinant was 0. Therefore, it's a singular matrix or not a non-invertible matrix. It's a non-invertible matrix. It has no inverse. So a singular matrix. Matrix whose determinant is 0. So, but in this case, you see, we are not using determinant. With the row reduction method, we are just putting it in a row echelon form. So we're not using determinants. So we shall still check whether this has, let us see the magic it will give us. Let's see what it will give us. Question 3, we have that the matrix E is equal to, by row, is 1, negative 3, 17, 1, negative 1, 7, 2, negative 5, 29. Alright, so let's write it in augmented form. 1, 1, 2, negative 3, negative 1, negative 5, 17, 7, 29. 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's do the operations. We need this to be 0 and this to be 0. So this is negative R1 plus R2, and then negative 2R1 plus R3. If we do that, what we got? What do we have? Row 1 does not change. We write it like that. 1, negative 3, 17. 1, 0, 0. Negative 1 plus 1 is 0. Negative 3 is 3. 3 minus 1 is 2. Negative 17 plus 7. Negative 17 plus 7 is negative 10. Negative 1 plus 0 is negative 1. Negative 0 plus 1 is 1. Right? Negative 1, 0 plus 1 is 1. 0, 0 is 0. Then here, negative 2 plus 2 is 0. Negative is positive. 2 times 3 is 6. 6 minus 5 is 1. Negative 34 plus 29 is what? Negative what? Negative 34 plus 29 is negative 5. 40 minus 9 is 5. 29. Yeah, 40 minus 9 is 5. Right? Then negative 2 plus 0 is negative 2. 0, 0 is 0. And 0 plus 1 is 1. Right? This is what we got the first time. Now, let's do another operation. We have to make this 0 and this 0. Remember, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this will be, what operation do we use now? Negative, well, we not because this is negative and this is positive. So this is 3R2 plus 2R1, and then positive, positive. What is positive, positive, or negative, negative? You have to apply negative here. Negative R2 plus 2R3. Because negative 2 plus 2 times 1. So negative 2 plus 2 is 0. So row 2 does not change. We write 0 to negative 10. Then negative 1, 1, 0. 3 times 0, 0. 2 times 1 is 2. 3 times 2 is 6. 6 minus 6 is 0. 3 times negative 10 is negative 30. Negative 30 plus 34 is 4. 3 times negative 1, negative 3, plus 2 times 1, 2. Negative 3 plus 2 is negative 1. 3 times 1 is 3, plus 2, 0. So this is, 3 times 1, yeah, 3 times 1 is 3. 2 times 0 is 0. So 3 plus 0 is 3. Negative 3 plus 2 is negative 1. 2 times 1, 3. Okay. 0, 0 is 0. Then 0, 0 here is 0. Negative 2 plus 2 is 0. Negative 10 is 10 minus 10 is 0. Negative 1 is 1. Negative 1 is 1. 1 plus 2 times negative 2 is negative 4. So 1 minus 4, right? Negative 1 is 1 plus 2 times negative 2. So 1 minus 4 is negative 3. Then negative 1 plus 0 is negative 1. Negative 1 plus 0 is negative 1. Then 0 plus 2 times 1 is 2. Okay, there is a problem here. Right? Let's double check. Negative 1 plus negative 1, and then 0 plus 2 times 1, 2. Okay. 1 plus 1 minus 4 is negative 3. Okay, folks, you see, there's a problem here. We can't, even if we interchange this, it's gonna be a problem. It's gonna be a problem. We can't make this to be an identity matrix. It's causing us problem. Assuming we interchange it, assuming you say interchange it, assuming we interchange it, we now have 2, 0, 4, negative 1, 3, 0, 0, 0, 0. You see, it will still be 0, 0, 0, not 0, 1, 0. So this is like a no solution. It's no solution because you can't make this to be an identity matrix. So it's no solution. It's just like when we later on when we do a solution of linear systems using yeah, we've done that. Then we did that with 2 by 2 matrix. We shall still do with 3 by 2 matrix. But if you're looking at this, you see that it's like saying you can't. The thing is, you can't make this to be an identity matrix, and because you cannot make it to be an identity matrix, it does not have an inverse. No inverse. No solution. Alright folks, thank you so much for listening to this video. I hope you enjoyed it. If you have any questions, please ask them. And you have a good evening.